Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. So today we're going to be jumping into Unit 5, Lesson 3. Our main topic is complex fractions. Don't forget to put your first and last name, period, and the date in the upper right-hand corner of your paper. Our objective today is I will simplify complex fractions as well as state any restrictions on the variable. Mastery will be demonstrated by scoring at least 80% on the extra practice. All right, so before we dive into this brand new concept of complex fractions, we're going to review what we did in our last lesson and just practice adding and subtracting regular fractions and rational expressions before we jump into what a complex fraction is. So for 2m over 3 plus 5m over 2m squared, I'm going to need a least common denominator to be able to combine these two rational expressions. That least common denominator is going to need to include 3, 2, and m squared. So the first fraction, 2m over 3, actually, I'm going to do that like this, is missing the 2 and the m squared in the denominator. So I'm going to multiply the denominator and the numerator by 2m squared. The second fraction, 5m over 2m squared, is just missing the 3 in the denominator. So I'm going to multiply the top and the bottom by 3. So I get 2m times 2m squared is just 4m cubed plus 15m all over 2 times 3 would be 6m squared. Then 4m cubed plus 15m. Let's see, could that be, yeah, we could factor out an m from both of those terms. And we would get 4m squared plus 15 all over 6m squared. So remember 6m squared is really 6m times m. And then m divided by m is 1. So we have 1 times 4m squared plus 15 in the top all over 6m. And then our only restriction then is that m would not be allowed to be, well, what would make m to the second and m to the second is the only thing we have in our denominators here. What would make those 0? Well, if m was 0, because 0 squared would be 0 times 6 is 0. So m can't be 0. All right, now you try one. So 2 over 3y squared minus 6x over 4xy. Go ahead and give that a shot on your own. When you get to listing your restrictions, there's going to be 2 variables because you have an x and you have a y in your denominator. So you're going to have x can't be equal to and y can't be equal to in your restrictions. Go ahead and give this a shot on your own. All right, so I figured out that my LCD needed to include 3, 4, y squared, and x. I multiplied the first fraction by 4x. I multiplied the second fraction by 3y. So then I ended up with 8x minus 18xy all over 12xy squared. I noticed that I could factor 2x out of both of the terms in the numerator. So that got me 2x times 4 minus 9y all over 12xy. Well, 2 goes into 12 6 times. So I can reduce 2 and 12 by 2. So I get 1/6. X divided by x becomes 1. So I have 1 times 4 minus 9y all over 6y squared. And then x can't be and y can't be something. Well, I have y squared left in my denominator here. So y isn't allowed to be 0. And then I also had an x in my denominator, and that is also not allowed to be 0 either, because if we plug in 0 for x there, we'll end up with 0 in the denominator. All right, there we go. Now let's look at a complex fraction. So example 2, part A. Our directions are that we need to simplify the complex fraction, then state any restrictions on the variable. So for our complex fraction, we have 1 over 1 plus xy. So the reason why this is called a complex fraction is because you have a fraction that has fractions in the denominator or in the numerator that are being added or subtracted. So it's a complicated fraction. The first thing I like to do when I solve these problems is I like to remind myself, what does a fraction bar really mean in algebra? It really means divide. So what this says is 1 divided by 1 plus x over y. And then I put that in parentheses because we need to simplify that. So let's do that. Let's get this thing simplified. So 1 can't be simplified further, divided by, and then I have, well, 1 is technically 1 over 1 plus x over y. To be able to add these two fractions and combine them into one fraction, I need a common denominator. Well, my least common denominator would need to include a 1 and a y. Well, 1 times y is just y. So the first fraction needs to be multiplied by y over y. The second fraction would just need to be multiplied by 1. That's not going to change anything, so I don't need to worry about it. So I've got 1 divided by 1 times y is y, 1 times y is y. Now my denominators are the same, so I can add my numerator and combine this into one fraction. So 1 divided by y plus x all over y. Now, what else do I know about division and fractions? I know that I can change my division to multiplication if I flip the second fraction. So I can change this to 1 times y over y plus x. Well, what's 1 times y over y plus x? Well, technically, again, this is 1 over 1. 1 times y would be y over 1 times y plus x is just y plus x. All right. And then, oh, we actually need to state our restrictions. So for y plus x to be 0, y and x would have to be 0 at the same time. You'd have to have 0 plus 0 to equal 0. So y can't be 0 and x can't be 0. And there we go. All right, let's do the next one. So part B, x over 1 over x plus 1 over y. I want you to go ahead and give this problem a shot on your own. Follow the same steps we just did. Rewrite it using a division sign instead of this fraction bar right here. Then combine the fractions into one fraction, change your division to multiplication, and simplify and state your restrictions. Go ahead and give it a shot and see what you get. Yeah, okay. So I actually want to walk you through all of these steps. For our least common denominator, I figured out it would be xy to be able to simplify the 1 over x plus 1 over y. I just changed the division, the fraction to a division sign, and then put the denominator in parentheses here. We're going to combine them into one rational expression. So if my least common denominator is xy, the first fraction is missing y, so I multiply it by y over y. The second fraction is missing x, so I multiply it by x over x. So from there I have x divided by y, 1 times y is y, xy plus 1 times x is x over xy. Now my denominators are the same, so I can combine them into one fraction. I'm going to have y plus x over xy. Then I'm going to change my division to multiplication, but I have to flip the second fraction. So I have x and then y plus x. Just kidding, I'm going to flip that like I said. Xy over x plus y. Then x is technically over 1. So when I multiply this, I'm going to have x times xy over 1 times x plus y. X times xy is x squared y over x plus y. And then we need to state our restrictions. So x can't be, well, up here in this fraction, we had x and y in a denominator. We originally had x and y in denominators here. So neither of those are allowed to be 0 because then you'd have 1 over 0, 1 over 0. So x and y can't be 0. And that would be the same case for x plus y in the denominator here. If you had 0 plus 0, you would get 0 in the denominator again. So we're good to go. All right, hopefully you were able to figure that out. So now let's do a more complicated complex fraction. So 1 over x plus x over y, all divided by 1 over y plus 1. So we're going to take the top, we're going to do 1 over x. We're going to make sure we put that in parentheses or brackets. Then we're going to change the fraction bar to a division sign. Then we're going to put 1 over y plus 1 in brackets or parentheses as well. So for this first set of rational expressions, 1 over x plus x over y, our least common denominator, again, is going to be xy. We're going to multiply the first fraction by y over y. We're going to multiply the second fraction by x over x. All right. Then for this second set, 1 over y plus 1, well, this 1 is technically over 1. So my least common denominator would just need to include 1 times y, which is y. The first fraction doesn't need to change. The second fraction needs a y in the denominator. So we're going to multiply it by y over y. Now let's start multiplying. So 1 times y is y over xy. X times x is x squared over xy. And we're going to divide that by 1 over y plus 1 times y is y, 1 times y is y. So y over y. Then, because the denominators are the same, we can add the numerators. So y plus x squared over xy divided by 1 plus y over y. And then now we don't really need the brackets anymore. So we have a fraction divided by a fraction. So remember, what can we change that division sign to? We can change it to multiplication, but we have to flip the second fraction. So y plus x squared over xy times y over 1 plus y. Ooh. Well, y divided by y is 1. And then I don't think anything else simplifies. So we have 1 times y plus x squared over x times 1 plus y. And make sure that 1 plus y is in parentheses. But now we need to state what x and y can't be. So right away, I see that x can't be 0. Y can't be -1 because 1 plus -1 would be 0. And then we have a y in a denominator here and here. So y and here. So y also can't be 0. That's not allowed. And I think that's all the ones we need to worry about. We already said x can't be 0. All right, there we go. It wasn't too bad, was it? All right, why don't you go ahead and give part D on a shot? Part D, what did I just say? Why don't you give part D a shot on your own? Sorry. So for part D, you're going to have 1 plus 2 over x, all divided by 2 plus 3 over 2x. Follow the same steps that we did before. See how far you can get with this problem on your own. So press pause and then press play when you're ready to check your work. I figured it would just be easier for me to walk you through all of my steps and explain them while you check your work compared to mine, since there are a lot of components here. So I just rewrote it so that with this fraction bar, I just changed it to a division sign and divided the numerator and the denominator. Then I noticed that my least common denominator for 1 and x would be x. My least common denominator for 1 and 2x would be 2x. The first fraction is missing the x, so I'm going to multiply it by x over x. The second fraction isn't missing anything, so we're good. Then in 2 over 1 plus 3 over 2x, the first fraction is missing 2x, so I'm going to multiply by 2x over 2x. And the second fraction is fine. So then 1 times x is x, 1 times x is x. 2 times 2x is 4x. And then 3 over 2x. All right. And now that we have the same denominators, we can go ahead and add to simplify. So x plus 2 is x plus 2. I don't know what I was about to write there. Over x divided by 4x plus 3 over 2x. Now, hopefully you recognize, because we have a fraction divided by a fraction, we can change it to multiplication and flip the second fraction. So you should have x plus 2 over x times 2x over 4x plus 3. Well, x divided by x is 1. So we have x plus 2 times 2 times 1. And then 4x plus 3 is left on the denominator. So then what is x not allowed to be? So remember, we had an x in one of our denominators here, in a bunch of our denominators. So x is never allowed to be 0. Then we also have, I think that's it till we got to the end and then flip this fraction. Now we have 4x plus 3 in a denominator. So what would make 4x plus 3 0? And if you can't do that in your head, you should set it equal to 0 and solve for x. So the x value that would make that denominator 0 is -4, just kidding, -3/4. So x can't be 0 and it can't be -3/4 as well. All right, let's do an even more complicated complex fraction. Now they're starting to get fun. All right, so in part E, we have x minus 2 over x plus 2 over x plus 1. And all of that is being divided by 3 over x minus 1 minus 1 over x plus 1. There's a lot of division, a lot of fractions in this thing. So we're going to do what we did before. We're going to rewrite it so that x minus 2 over x plus 2 over x plus 1 is in brackets. We're going to change this giant fraction bar to a division sign. And then we're going to put what was in the denominator of this complex fraction in another set of brackets. So 3 over x minus 1 minus 1 over x plus 1. All right, so this time, the least common denominator for x minus 2 over x and 2 over x plus 1 is going to have to include an x and an x plus 1. Our least common denominator for the x minus 1 and x plus 1 is going to have to include x minus 1 and x plus 1. Notice I put those in parentheses because for least common denominators, we want to be multiplying those things together. All right, so our first fraction within a fraction is missing the x plus 1 component. So I'm going to multiply the top and the bottom by x plus 1. The second fraction is missing the x component. So I'm going to multiply it by x. Sorry, I was trying to color code those for us. Then divided by, still got our brackets. 3 over x minus 1 is missing the x plus 1. Put that in parentheses, multiply it by x plus 1. Then minus 1 over x plus 1 is missing the x minus 1. Get that bracket back. All right, so x minus 2 times x plus 1 plus 2 times x all over x times x plus 1 divided by 3 times x plus 1 minus 1 times x minus 1 all over x minus 1 times x plus 1. All right. Let's see. Now we need to change this to division, or to multiplication, sorry, and flip the second fraction. And when I do that, so x minus 1 times x plus 1 is going to be in our numerator now. When I flip it, I'm going to go ahead and also distribute and simplify. So we're going to have 3x plus 3 minus x plus 1. And this first fraction we are going to have x minus 2 times x plus 1. So x times x, we got to like distribute all this stuff. So x times x is x squared. X times 1 is x, negative 2x, negative 2, and then plus 2x. All right, let's simplify what we can. So negative 2x plus 2x will cancel. We're left with x squared plus x minus 2 over x times x plus 1 times, and then x minus 1 times x plus 1, all over 3x minus x is 2x, 3 plus 1 is 4. So let's see what else we can factor here. X squared plus x minus 2 might be factorable. This is already factored. And then 2x plus 4 is a GCF of 2. We're going to factor that out. All right, so x plus 2, let's see, x times x would get us x squared. 1 times 2 will get us 2. A positive 2 and a negative 1 will get us a positive 1x in the middle. All right, check it out. X plus 1 divided by x plus 1 is 1. X plus 2 divided by x plus 2 is 1. So what we're left with is x minus 1 times x minus 1 all over 2 times x, or 2x. But then we also have to list all of our restrictions. What is x not allowed to be? Well, in our final answer, 2 times 0 would be 0, so x can't be 0 here. Up here, before we started simplifying, x plus 1, negative 1 would make that 0, so that's not allowed. And x plus 2, negative 2 would make that 0. That's not allowed. So remember, we're just checking our denominators. So negative 2 would make this 0. That's not allowed. We already have it though. And negative 1 and 0, we already have that. Going back up. So we have to go all the way back up through our steps, because at this step right here, x minus 1 and x plus 1 are in a denominator. So what would make x minus 1 0? A positive 1. And then x plus 1, negative 1 would make that 0, but we already have it listed, so we're good. And then we got to keep going up through all of our steps. Let's see here. I'm going to go all the way up to our original problem. So 0 would make that denominator 0, negative 1, positive 1, and negative 1, which we already have 0, 1, and negative 1 listed, I believe. So we're good to go. 0, 1, and negative 1. So that's our final answer. X minus 1 times x minus 1 all over 2x, and x can't be 0, negative 1, negative 2, and 1. All right, so now I want you to try one of these more complicated problems on your own, all by yourself. So part F, do x minus 5 over 2x minus 5 all over, so all of that's being divided by x minus 5 over 2x minus 5 minus x plus 2 over x minus 5. Go ahead and give that a shot. Press pause and press play when you're ready to check your work. Again, I'm going to walk you through the steps as I write them, so that way you can compare your work to mine. Since there are a whole bunch of steps, I think that'll just be easier to keep track of what's going on. So in x minus 5 over 2x minus 5, this top part of the fraction, I put that in its own brackets here. Then divided by, I just changed this giant fraction bar to division. And then I put x minus 5 over 2x minus 5, x plus 2 over x minus 5 in its own brackets here as well. So my least, I don't even need a least common denominator for the first bracket, because there's nothing to add or subtract that, like between fractions. So I'm done simplifying that one. Then for the second one though, we're gonna have a least common denominator of 2x minus 5 times x minus 5. So again, I'm just gonna leave this first fraction alone. I don't even need brackets around this thing anymore because there's nothing to simplify there. Divided by, and then I'm gonna have x minus 5 over 2x minus 5. That fraction is missing the x minus 5 component of our LCD. Then the second fraction is missing the 2x minus 5 of our LCD. Oh, you know what? I forgot all these parentheses. We're multiplying all that. So don't forget your parentheses. All right. Then, now that our denominators are the same, I can combine this into one fraction with the denominator of 2x minus 5 times x minus 5. The top is x minus 5 times x minus 5 minus x plus 2 times 2x minus 5. Now, since you have a fraction divided by a fraction at this step, you could change this division to multiplication and flip this fraction at this step if you wanted to. Or you could simplify that numerator first. I'm not too worried about that, however you did your steps there. So I'm going to flip that fraction. I'm going to put 2x minus 5 and x minus 5 up top. Then I need to simplify this numerator though. I'm going to multiply x times x minus 5 and negative 5 times x minus 5. I get x squared minus 5x minus 5x plus 25. Then I'm going to have a negative, and I'm going to multiply x plus 2 times 2x minus 5. I'm going to get 2x squared minus 5x plus 4x minus 10. Maybe at that last step, you realize that negative 2x minus 5 divided by 2x minus 5 is going to simplify. If not, that's fine. X squared minus 10x plus 25. And then I'm going to distribute this negative. This would become negative x. So I'm going to have negative 2x squared plus x plus 10. So x minus 5 over 2x minus 5 times 2x minus 5 times x minus 5. Negative x squared. Okay. Negative 10x plus x is negative 9x. 25 plus 10 is 35. Now we need to see if this denominator right here will factor. So the first thing we want to do is factor out the negative because the first term is negative. We're going to have x squared plus 9x minus 35. And let's see if that will factor. It might not. See, x and x, 5 and 7. That doesn't make positive 9. Okay. So if that's not going to factor further, then we can just start simplifying. So 2x minus 5 divided by 2x minus 5 is 1. We're left with x minus 5 times x minus 5 up top, and then negative times x squared plus 9x minus 35 in the denominator, and then x can't be. So we have to figure out all of the things that would make our denominators 0. Well, going back up a step here, in 2x minus 5, what would make that 0? If x equaled 5 halves. So we don't want x to be 5 halves. Going back up, we also don't want, we've got x minus 5 in the denominator in a couple different places. So we also don't want x to be 5. And then we also need to see if there are x values that will make x squared plus 9x minus 35 0. So we're going to have to do a little extra work on this problem. X squared plus 9x minus 35 equals 0. So we can solve this a whole bunch of ways. Well, we can't factor it. So we could solve it by completing the square, or we could plug it into the quadratic formula, which is what I'm going to do. So x equals the negative of 9 plus or minus the square root of 9 squared minus 4 times 1 times negative 35 all over 2 times 1. So x equals negative 9 plus or minus 81 let's see here. What is 4 times 35? All over 2. So negative 9 plus or minus plus 81 is 221 all over 2. Does anyone go into 221? I don't think so. 17 does. 17 times 13. So there's no groups of 2 under that radical that we can bring out. So x also can't equal this. So we're going to add that to our list. X can't be 5/2, it can't be 5, and it can't be negative 9 plus or minus root 221 all over 2. Fun times. All right. So make sure you do your extra practice, get that submitted to Schoology, and then hit that ask for help button when you're done. I'll jump into your breakout room and go over it with you. All right. Have a good day, guys. See you back in class.